Yes. So basically, in industry, we have designated individuals to perform this first task. The first task was to create or to convert these text requirements or requirements informally written in the text documents, SRS document, to convert them into the conceptual representation of the requirement, which was ERD. So this activity, this very first activity, is done by the different specific individuals named as a business analyst, right? So in industry, in different industries, actually, whenever we need a database to basically manage the system operation or the software operation, we used to call business analysts to convert these requirements into ERD. So business analyst individual will be collecting all these requirements from the clients, and first he will be recording these requirements into the SRS document, which is a formal document. Then further he will be basically mapping these requirements into the ER representation, because ER representation will be helping you as a programmer. So suppose you are a DBA now, so this ER diagram or ER representation will be easy to understand or easy to convert into the actual database. So first task in the database design lifespan, first task which is mapping of these text requirements into the visual representation in the form of ER diagram, will be done by business analysts. That is the first task, right? After that, we have discussed that this database creation. So where basically we have then this mapping of ER diagram into the logical schema or logical representation, or maybe actual database table. So this is the second task. Now, second task is usually done by either by DBA or by a database programmer. Now, in the first place, we have business analyst. Now we are having the role of database administrator. That is the person who will be able to converting these ER representation into the logical schema, or maybe he will be creating the representation of logical schema in the actual table. So second individual, or the second level, we have database administrator, DBA, or maybe the programmer itself, who will be basically creating these database tables, right? So in the lifespan of a database design, so suppose you are controlling a team as a project manager, who is responsible for creation of this database. Then you need to have a presence of, or your team will have these two individuals. So first you will have business analyst with you, then we will have a DBA or maybe programmer. So this whole team usually refer as a DB team in industry, right? So the second task is basically creating these tables actually in the database or in the system. Now after this, we thought that, okay, so we have done with these two activity. Now we have with us this whole properly created database, and in the database we have inserted database records. So can we use it? Yeah. So many of us are having this perception that once we have this database with us, we can directly perform our operations on that, right? So one thing you should be having very clear that if your database is made or created for a limited number of users or limited number of operations on it, you can go with the current state. So whatever database you have created, you can use it for, or you use it to support the user operation. But if your database, or if your system which you have created to run on a database, if that system is going to support, or it may be utilized by the lakhs of users, millions of users, or hundreds of users, that too concurrently, right? So there are two states. So either you have a database system there, we have millions of users, but they are not going to access a data item or data value concurrently. That's one state. Second state is that your software system will allow these millions of users to perform concurrent access on a particular data value. So basically there we have two kind of arrangements. So if you in both cases, your database system will not able to take care of, or will not able to handle this data values, operations on these data values, right? So typically, if you have created a database which is or which may be used by the real-time operations or real-time users, the perception which we have will not work actually, right? So you need to, so after creating this database thing, so everything we have created, every data value have inserted. Now with this perception, we cannot go for support for the user, real-time user or real-time operations, those on the scale of millions, right? They will have a lot of problems, lot of operational issues, lot of processing issues, right? So that's why, so that is the need actually. Okay, naturally we will be discussing, or we will be pointing out these specific issues or reasons uh, because of which we are going to discuss this new topic, or this new whole chapter, which is called data design, right? It is not database design, it is a data design, because data design is a part of database design. So we are talking about data design. Data means, so everything which we have is uploaded, right? So we are not mentioning, or we are not pointing on the schema part, we are simply pointing on the data stored into it. So you need to perform some kind of design operation on the data stored, data kept, or data state, right? So that's why this new chapter or new concept is called data design. And this whole purpose of data design, now I'm telling you the purpose, objective. So usually it is being asked that what is the purpose of data design, how it is different from the database design. So the purpose of data design, our focus for the next 2-3 lecture, the purpose of data design is to basically make a database or arrange data values in a manner through which we can efficiently perform user operation without having any is basically, there are terms called spurious. Spurious means it is misleading, or any data which is causing cascaded or additional or maybe excessive number of follow-up operations. So suppose there is a simple request by some user to perform anything on a data value, and based on this simple user operation, if data is not properly placed on a manner, your system will basically create, or maybe if raise a different number of repeated operation after that user operation. So likewise, right? So we will be exploring, or we will be discussing these specific points on a detailed way, and we will be taking out, or we will be discussing the solution for it, right? So that is the focus of data design. So you will have a specific approach to make your data, to place your data in the database in a manner through which we can support these basic operation, and make your database more effective and efficient for the user operation, right? So this theory of more or less usually what happens, a student perceives that there is a theory called normalization, right? So whenever I say what is data design, they used to say it is a normalization. No, it is not that. Normalization is one approach. Data normalization is, or database normalization is one approach or one solution through which we can place, or we can make our data values within the table, within the database table, in a way that so there will be no conflict actually. Each user operation, or each transaction, or each action of user request will be performed smoothly, right? It will not create any spurious thing. It will not create any redundant thing, or it will not lead up to the null value. So all the issues which we are going to discuss now will be taken care by the concept of normalization. So normalization is one solution. We can have other solution also. Yes, there are different solutions available, how to deal with this data design concept, and how to implement this data design concept, right? But one thing is very important, because we are now in the third phase of the database design. After doing first two steps by these different users, now we are in the third stage of database design. And this particular third stage or third phase will be done by individuals in the industry called database designer, right? So database designer will be performing these tasks, right? And it is obviously that this data design will be performed after the completion of first two phases, first two steps, right? Now let me share the particular notes which I've prepared for you to discuss this concept in detail. So I hope this is visible to you now, right? So we are going to discuss primarily, so this is what called data design theory. So we have partially touched upon the objective and why we are having this data design theory as a important concept or important topic in the syllabus. And after that, we will be taking this concept of called functional dependency. That's what it is, something, and it is the base. It is the first concept to perform. It is the first thing to perform data design, right? So okay, so now you have to see that okay, we have discussed several aspects to make or to create database ready for user operation. That's what we have discussed till now. So before going to use this database which we have created for user operation, you need to validate. So you need to see, and you need to clarify, or you need to basically tick upon that this current state of data, including schema as data values, both my database is basically perfectly okay, perfectly ready for user operation, right? So you cannot have it's not like, it is like basically acceptance testing. Like in software engineering, we used to say that testing has 4 levels, and in the third level of testing, we used to perform validation testing. Validation testing is kind of acceptance testing. It means now user who is going to use it have this kind of acceptance that okay, this software is being designed as per my requirement, because it is performing as I expected or I requested to the organization, right? So similarly, before going to use a database system or database state, it is important to validate it, whether that system is able to perform the task, will not create any malfunctions, will not create any malvalues in the database state, right? So that's what we used to refer, that the state of database must be in good. So if any database is having this kind of state, or maybe having this kind of presence, that it will have these following things inside it, it means the database is in the good state, right? So it is again, so evaluating or validating a data, whether a database is good or not, it is a subjective assessment. It is a subjective evaluation. So we cannot have any scale or range that for these 4 points or these 4 features or aspects, we need to score something like that. It is a completely qualitative assessment, right? So and it will be done by database designer. So database designer is the one individual who will be evaluating this current state of database, and he will be confirming that okay, now we can use it, right? So these 4 points are very obvious, right? These 4 points are very obvious, and you can see last 3 points out of these 4. So let me make in points way. So like this, right? So these last 3 points are something related to the manipulation of data, because in a database, we have discussed this part. In the database, there are broadly 2 types of categories of user queries which database will be getting, right? So in the whole life of database, we will be getting these 2 types of query from the user on the database, right? And for us as a database designer, for us, these 2 types of query as the only concern. Though we have this data creation queries also, we have data control queries also, but those are not the concern, because these both queries, type of query, are nothing to do with the data values or updation of data values, right? So our focus is on basically the user operations, which will be causing these 2 type of operations. So first kind of operation is retrieval, naturally. Second is of DML, manipulation queries, right? So whenever we are saying, or we are checking that a database which we have created is good, or is it fit or not, is it okay to use it or not? So you need to keep monitoring, or you keep take care of these 2 broad categories of database queries, right? So first set is naturally is about retrieval. So suppose we have created a database, company database. Now you want to share this database for the generic user, for the general user. So first thing you should be looking into the database, that whatever attributes we are going to have, right? Whatever attributes we are going to provide. So like what you need to see now, you have to see this database and this whole available attributes or GUI for the user. Like now we are talking about user, right? So yes, programmer will be there, right? Along with this programmer, we need to consider the presence of user. जो अभी तक हमने discuss किया है last around 15 lectures में. After 15 lectures, we have taken out this concept of presence of user. So we have not considered the presence of user. Now, because we are talking about कि ये database कैसे use करेगा users, you should be taking care of the presence of user and its effect, right? So that's why I'm saying we are in the third phase of the database design. There we should be taking care of the data values available and how different users will be accessing that database. It means, अगर आप कहते हैं कि user will be there, it means you will be somewhere talking about the user view, GUI, any GUI through which or on which user will be operating, right? Because a simple user, a naive user, will be operating on the database using some kind of interfaces, right? So primarily, whenever we say user is having some queries or user will be performing some operations, naturally to perform these operations or perform these instructions of user, you will be providing some GUI, right? And naturally on GUI, you cannot have list of all attributes. So suppose you want to serve some data values or you want to provide something to the user, you cannot list down all the attributes of a database table, right? You need to have some kind of or some set of attributes through which he will be able to access the remaining data, remaining records or remaining portion of data, right? So it is very important. The first thing is which is important that so whenever we create database, whenever we create user interface on the database, it is very important to identify. It is very important to identify appropriate set of attribute set. Appropriate attribute set means suppose a user is trying to access something from employee data. User is trying to access something from some other table. So it is not a suitable approach to list down all the attribute name on the GUI. It is not suitable to provide the details of all the constrained information and other things to the user, because that will that will create some kind of confusion, that will possibly create some kind of dilemma condition to the user, because he's not able to perform these selection operation on the attributes or anything. So it is better to have, or it is better to identify appropriate set of attributes through which you can access each value, right? Through which you can access each value. I'm saying value, not tuple, right? So some student might ask, sir, though we have primary key created in each table, so can we use primary key to access each records, right? So you should be having this clarity at this point that primary key cannot be used to access each record. Record means, so suppose we are dealing with employee table, each record means any value in particular cell. So like SSN number is, so in particular tuple, this SSN number, well, SSN value is one record. Date of birth value of any employee in the tuple is one record. So by using primary key, you cannot access these records uniquely, I'm saying, right? You cannot access these records uniquely, right? So that's why we cannot use only primary key. I'm saying we cannot access only primary key. We need, or we required some additional attributes, right? So suppose you are providing a GUI for the user to access the database, or maybe your application is providing some kind of operations, and your application is trying to have this list of attributes through which your application retrieve the remaining records or remaining data from cell values. You need to have appropriate attribute set, and this attribute set, appropriate or maybe optimal or maybe anything suitable, you will have additional attribute additional to the primary key. So it will have, like, suppose SSN is a primary key, then SSN will not be suitable enough, or it will not be sufficient enough. So you will have SSN and some additional attributes. right? So by having this this kind of arrangement, we can say that by using these 2 or 3 attributes of a database relation, we will be able to identify, or we will be able to retrieve uniquely each record. So I'm using 2 terms: uniquely determining, uniquely retrieving. So it is like uniquely means when we provide the values for these 2-3 attributes which we have identified as a optimal or appropriate, or let me place optimal here, optimal, right? So optimal means you cannot have the excess number, because that's what we are avoiding. We will have only limited number of attributes through which we can identify each record uniquely. There will be no confusion, right? Something like that. And this concept we will be discussing in details, that how to derive this optimal attribute set. And this optimal attribute set is referred as a candidate key. So candidate key is a different concept. Candidate key is having different purpose, right? It is not a similar concept to primary key. You should be taking care of this term, that primary key and candidate key both are different concept, right? Most of the students often get confused that the candidate key is similar to the primary key. It is not the case. Primary key is altogether for different purpose, and it will serve different purpose, right? But candidate key may consist of primary key attribute and beyond that also. So candidate key might have primary key and additional attribute, but you cannot say that candidate key and primary key both are same, because candidate key is having different purpose. The purpose of primary key is to define uniqueness among the tuples. That's the only purpose. Now we need a different set of attributes, and these different set of attributes are called candidate key. And the purpose of candidate key is to uniquely determine the cell, each records, right? So the single purpose of candidate key is to have a appropriate attribute set which will be able to uniquely determining or having this unique relation between each cell or each record in the particular tuple, right? But in the primary key case, it was to define this, or it was to ensure this uniqueness property in the table, right? So there will be no similar tuples will be there in the table. But candidate key is there to have this kind of arrangement through which you can ensure that each record in a tuple, so in a tuple, each record will be uniquely determined, right? By using these 2 attributes, you can uniquely determine each cell value in that particular tuple. That's what the purpose of candidate key. So we will be getting into the detail of these concepts: candidate key, super key, and other concepts, right? Now this is about a retriever. Now what if user operation may basically affect into a manipulation operation, right? So there are different reasons for that, because of which we need to see that your database is not in good state or bad state. So you need to see, right? So most of the people, most of the database readers often say that it should not have any redundant data. So redundant means you can take this typical example, like suppose in a university database or in a college database, we are keeping the records of students, like his roll number, first name, his mobile number, and email ID. So let's take this instance that department is keeping the detail of students, his phone number, email ID, and other things. Similar details are kept in academics. Similar details are kept in some of the database table with the TNPO. Some of the details is kept in the hostel also. So we are having, so in a single database, we are having this copy of phone number or email IDs into the 5 different tables, right? So 5 different offices in the single institute. We are having 5 different offices where we have kept the same information in the different relational database tables. Now, what if we are modifying? What if we are updating a phone number of a student? right? So if I update a phone number of a student, either student is informing that change of phone number to the department office. So there is two possibilities. That one possibility is that your database or your office is efficient enough to inform to the other offices that the phone number of this student has been changed. That is one possibility. तो वो तब होगा जब आपका डेटा ऑफिस प्रॉपर काम कर रहा है या कि आपका डेटाबेस सिस्टम प्रॉपर काम कर रहा है. It means whenever there is a change occurs, your database system or maybe actual office of the institute is perfectly working, and in the same time it will operate all the update all the perform update on the copies of the database. That's one ideal condition, but it is not the always case. So what happens अगर ये properly नहीं हुआ तो क्या होगा कि we have two phone numbers of the same student. ये होगा कि कुछ जगह ऑफिस में अपडेट हुआ, कुछ जगह अपडेट ही नहीं हुआ, and that is primarily happening because we have kept this redundant copies of the same data. We have kept the number of copies of the same data on the different database tables, redundant copies. So whenever we encountered with some update operation, whenever we encountered with these update operation, it will create some kind of complications. In the case of occurrence of updation, it will create some kind of complication, right? और अगर update नहीं हुआ तो retrieval में भी problem है. आप phone number search करेंगे तो you will get two copies of phone number. So basically because of redundant copies of the data, we'll have two problems. Retrieval में problem होगा. Retrieval में आपको incorrect version मिलेगा of the data, as well as operation जो करेंगे उसमें भी confusion है कि किस जगह reflect हुआ, किस जगह reflect नहीं हुआ. So these all possible problems are basically summarized into a term called anomalies. So anomalies means two things. Whenever we say database anomaly, it will lead to the anomaly. It means on the occurrence of any change, if your database values are creating some confusion or some excessive operations, it is referred as an anomaly, right? Similarly, we have this problem or this scenario is called null values. So it may possible that in a database table or maybe in the database there are some values, there are some columns where we have kept or we have forced to create these values which are referred as the null values. So ये बहुत ज़्यादा possible है कि बहुत सारे databases के tables में कई सारे columns में attributes में we used to keep or we forced to create null values, right? Because null values having three proper classification or three proper reasons, you can say, or three proper possibilities due to which we are forced to create these values a null value, right? So you cannot eliminate null values. In some cases it is kind of compulsion to keep null values, क्योंकि कुछ values आने वाली हैं, कुछ values एक time के साथ appear हो जाएंगी उसमें. So you cannot have a database without null value. But our intention to keep null values as less as possible. That should be intention. Because again, जैसे हमारे redundant data रखने में problem हुई, it has lot of it has reflected or affected into a lot of anomalies. Similarly, null values also may leads to the set of anomalies. So anomaly means updation में problem होगा. That's one part. Second, whenever we perform some retrieval query, it will basically result into a misleading data, some kind of thing, right? So these are the first three reasons which are based on which we are thinking that whenever we are going to use a data, you should be taking care of the current state of data, and based on these first three properties, you will be able to, or you are saying that database is good enough, it is on good state to be used. So if something is, if everything is okay with respect to these first three parameters, you can go for that. You can go for using this database, or you can make this database available to the users, right? So primarily, what I'm saying. So first point is about retrieval, right? So if your database system is not having this set of appropriate attributes, it is not in good state. If your database is having redundant data, then or it may be having null values, So because of these three reasons, or based of three parameters, you can identify that, or you can say that database is good or not good state, right? So from here, basically, you need to see, or you need to find out, or you need to point it out that uh, what is the role of primary key or foreign key we can use, right? So we have created primary key during this creation of logical schema, and that in the same time we have created the different foreign keys on the different attributes. So you need to see whether can we use primary key and foreign key to solve these three problems, right? So you need to see to it, and if not, what is the possible solution you need to work upon, right? So because a lot many researchers have been working on this direction, they have thought about the usage of primary key and foreign key to solve these problems. So can we use primary key to have this optimal set of attributes, or to deal with redundant data, to deal with null value? And they realize that by having this foreign key and primary key is not a sufficient solution, or will not serve any solution which will be taking care of redundant value scenario and null value scenario, or maybe the retrieval scenario. So that's why they thought of creating new constraints on relationship, because our focus is to basically have the suitable set of attributes, or basically having some kind of relationship based on which you can create, or you can have this 1:1, or some kind of relationship between the data attributes, right, between attributes. So the solution for these three possible basically limitation on the database, you will be having you may be having a solution which creates a relationship, deriving a new relationship between attributes of a table, or right, relational table or relational database instance, right? So by deriving the relationship between attributes in a table is one way, or one solution, based on which we can ensure that database table will have lesser redundant value, lesser null values, and it will have appropriate set of attributes for the retrieval. So that's based on this need only, this concept of functional dependency has been planned, or it has been created, right? So functional dependency is basically something you must have heard of about, that functional dependency. So dependency is again something you can clearly understand, and that if you want to determine some data value, if you want to determine some value, which data attribute you will be required, right? So dependency is to determine, right? So functional dependency means, literally means whenever user is asking for some data for his purpose, right? So whenever user is requesting for a data to serve his purpose, to complete his purpose, what is the minimum attribute, what is the attribute you need to retrieve the desired data, right? So you need to see functional or operational or business dependency. So dependency is to what? Dependency is to retrieve the data, right? So a functional dependency is a constraint between two sets of attributes. So you need to see. So whenever we are deriving, so now this is the task of database designer, right? Because we found that in the previous case, we found that the database is not good, it is not okay, it is not ready for to use, it is not ready to use by the different user. So now we have to perform this next task, which is called normalization, which is called data design, right? So for starting this data design task, to make the database operational, the very first step is to derive, or is to define, or is to create functional dependencies between pair of attributes. Pair of attribute means if you have this attribute, left side attribute, you can easily determine right side attribute, So that is the simple implication. It is a kind of constraint, right? So from the typical definition of functional dependency is that a functional dependency is a constraint between two sets of attributes from a database, right? So whenever, as a database designer, whenever we are deriving the functional dependency, so naturally, because in a database table there are different attributes, it means there will be different functional dependencies, right? Now, so what is the logic, what is the basis of which we are defining these functional dependencies, right? So that's what we are discussing in the next instructions. Like, to denote this functional dependency, it is denoted by, so let me mark like FD. So let's abbreviate it, FD. FD is denoted by X determines X. So this is not a proper symbol I'm using. It will be like, it is a simple arrow. So X is determining Y. So it means, this means if you have the value of X, if you have, so if user is having value of X, he is able to access the value of Y. That is the simple implication of this functional dependency. It means, agar aapko, as a database designer, if you see in the database state and found that each value of X is determining or related to value of Y uniquely, right? You can say that X is now for all the tuples between X and Y, all the tuples are related in this relationship, that this unique value of X is determining unique value of Y, something like that, right? Then only you can say that in a database, in the database table, this relationship holds, this functional dependency holds, right? So FD is denoted by X determines Y between two sets of attributes X and Y in the database relation R. So here, this relation R, this database table R is having only two attributes X and Y. Similarly, the FD specify a constraint on the possible tuples that can form a relation state R of R. So basically, R, small r represents here state, right? So that's what we have said. So because in any real-time database, the data values at any point of time is called state. So this capital R represents the whole database. I mean, it is representing a database, but any point of time state of database is called small r. So it is kind of creating instances, right? The third condition says the constraint that is, so basically it is now defining the FD. So for any two tuples T1 and T2, so suppose we have two tuples T1 and T2 in the database state R that have T1 of X means value in X column. So for tuple T1 and for tuple T2 on column X, if both are same, if both values on column X are same, they must have T1 of Y, T1 of 2, right? So it is like creating unique relationship, right? So whenever we have this value on X, it will have this relationship value of Y uniquely. So whenever this value of X is again repeating in some other tuple, it will have this again same occurrence of value of Y as appear in the previous case. This means that, literally means that the values of Y component, Y attribute of a tuple in R depends or determined by the value of X component, right? That's what we are discussing. So whenever we have given this X value or value of X attribute, it will be uniquely determining or it will be uniquely mapping with the value of Y. Third, so the value of X component of a tuple uniquely determines the value of Y component. Right. So this is a simple interpretation of it. And here you can, so because we are having this X value attribute X, which is able to determine all the values of Y uniquely, you can claim that for me or for this database table, X is a candidate key, right? We are not going to use term primary key. We are not going to use it, right? Because we are working on a third phase, on a third step of database design, and we are trying to derive some set of attributes. We are making the data values operational. We are making it basically in a way based on which we can smoothly perform retrieval and smoothly perform updates, right? So that's why we are using term candidate key. So now this is the simple definition of functional dependency. So if someone asks you that what is a functional dependency, you must be saying that so it is a relationship between pair of attributes, right? It is a relationship, it is a constraint between pair of attributes in a relation, right? So whenever we are defining a functional dependency, it is always for a database table, right? एक डेटाबेस में बहुत सारे टेबल्स हो सकते हैं, हर टेबल के अपने सेट ऑफ एफडीज होंगे. अब एक टेबल में अगर मोर देन वन एट्रीब्यूट है, जैसे अगर हम एक कोई टेबल लें आर जिसमें 3 एट्रीब्यूट्स हैं एक्स वाई जेड, सो इट कुड हैव, सो बेस्ट पॉसिबल केस ये होता है कि एक ही फंक्शनल डिपेंडेंसी हो, लाइक एक्स डिटरमाइंस वाई जेड. ये भी केस हो सकता है कि एक्स डिटरमाइंस वाई, वाई डिटरमाइंस जेड, समथिंग लाइक दैट. सो 2 हो सकते हैं. सो बेसिकली हर एक डेटाबेस टेबल का अपना फंक्शनल डिपेंडेंसी सेट होगा, right? That is for sure. And whenever we are creating or identifying these FD as a database designer, you should be taking care of, or you should be using these following information. So what is the source of information to derive the FDs in the relation or table? What is the possible source? So we have listed down. Sometimes it is easy or it is obvious to use the key constraints, right? Key constraints like PK, foreign key, not null also, unique also, unique, any constraint you can use. I mean, based on which you can think of that there is a possibility of this function dependency between pair of attributes, right? So sometimes you can use these constraints. The most important source for defining the foreign functional dependency is data values in the domain of the attributes, right? Because if you want to determine, or if you want to establish these FDs between attributes, you should be thinking about the domain of the these attributes. That is for sure, actually, right? After that, this meta information or requirement. So because by reading to the requirement document, by reading the requirement documents or any additional information, sometimes these informations will be helping you as a database designer to create the FD between the relation, between the attributes, actually, right? So with this, now I'm assuming that because this creation of FDs involved to derive or create the as a database designer, right? So we have marked as important. So now you should be basically having this kind of aptitude, or maybe some kind of exercise of experience, based on which you can easily find out, or you can easily derive the set of FDs. Naturally, to derive the functional dependency for a database relation, you should be using of these things, right? So पहली बात तो obviously है कि अगर आप पास एक सामने database table given है, you should be easily identifying that. So suppose there is database table given to you, and in that table there are 5-6 attributes, and in attributes we have listed down the values also. So one thing is very common, that by hit and try approach you can derive the possible FDs. That okay sir, I can see that this first attribute is having this unique determination approach, that by using some unique value of first attribute you can able to derive the second or third attribute, or maybe pair of attribute also. So it will be like A is determining B, D, A and B is determining D, something like that. So you should be listing all the possible values. It can be in the reverse way also, that D is determining A and D is determining B also, and B is determining C also, something like that. So you should be having this kind of experience or some kind of aptitude based on which you can derive the list of FDs. Right. So the first set of FDs you can derive. Right. That is basically is the responsibility of database designer. And naturally, it requires some kind of experience. So I request each of student to take a one database table and database table with the values naturally, and tries to create the possible FDs. Right. So now beyond this, so naturally as a database designer, in the first instance, you will be creating the basic, fundamental or basic set of FDs on a database table. But there are other FDs which can be created by using this first set which you have created, right? And to create the additional set of, to derive the additional set of FDs, you will be using these inference rules. Inference rules are basically some kind of principles, some kind of instructions available through which you can derive the additional or the new FD. So, right. So to derive these additional or new FDs, you need these kind of 6 rules, right? So let's take these rules, and each and every rule is having some kind of definition also. So you can see the first rule says, which is referred as a reflexive rule. It says that you should be having, if you are having in a database relation, if you have derived that X determine Y, it means X is determining Y uniquely. It means you can say that yeah, that might be some kind of mistake here. So you can say that like this also. So I can say that if there is a FD which says X determines Y, X uniquely determines Y, it means, or you can say that Y uniquely determines X also, right? So that's, so if something is given like that, so if you have derived some FD like this, you can derive this additional FD, right? Second rule says, second rule is called augmentation rule. It says that if some FD is given like X determines Y, you can derive new FD named as a XZ determines YZ. So here we have appended this Z attribute in both sides, right? So based on this X determines Y FD, you can derive new FD, which is like XZ determines YZ. So we have added Z attribute in both sides of a FD. Similarly, there is this third rule, which is called referred as a transitive rule. So transitive rule says if there are some FDs you have derived like X determines Y, and in the same set of FD which you have derived, there is a FD called Y determines Z. So if these two FDs are available in your set of functional dependencies, you can design or you can create new FD called X determines Z, right? So this is called transitive rule, right? X by X you can determine Y, and Y is determining Z. So you can claim that, or you can derive that you can easily access the Z attribute also. That is what transitive rule said. Third, then the fourth one is called decomposition or projective rule. So decomposition is splitting into basically. So here, if some FD is like X determines YZ is available, YZ is defined, you can split into two FDs. First is called X determines Y. Second will be X determines Z, something like that, right? So with this, you can say we have decomposed into, so there is this FD which you have derived, X determines YZ. Now you can further derive or assume that these two FDs are possible based on the initial FD which I have identified. Now next rule is called union. So union or additive, which is too obvious that if you have created or identified that there is this FD X determines Y and X determines Z exist, you can make it union and says X determines YZ, right? So this FD, X determines YZ, can be derived or it can be created. Right, and last one is called, last inference rule is called pseudo transitive. So transitive something which we have taken out. Now pseudo transitive says if you have derived FD called X determines Y and another FD called WY determines Z, then you can derive this FD WX determines Z. Right, so it is simply replacing this Y factor actually and deriving a new FD. So by utilizing these six inference rules, you can simply derive the additional set of FD. So, because deriving the all possible FD will basically leads to the best data design. That's what the importance. So, the very important task of database designer is to derive all the possible FDs in a database table. Right, so this is something which we are closing today. Right, so in the next lecture we will be taking, or we will be discussing how to derive other things from this set of FD. Right, so to perform each and everything in the data design, you need to have a proper set of FD. That's what is the basically the task of database designer. So once you have derived all the possible set of FD for database table or relation, you can easily work upon, or you can easily perform the task which is called normalization, right? Right. So naturally, to perform normalization, there is a step, middle step, which is called deriving candidate C. So in the next lecture, we will be discussing how to derive the candidate key, and how to use these candidate keys for performing normalization. Right. So in the next lectures, we will be discussing these things in the detail.